All right, waiting to go live. Let's see here. Should be live now. Let's make sure the audio is okay. All right, waiting to go. Okay, looks good. So welcome everyone to a recording session for Tech Talk Tuesday. So this is Tech Talk Tuesday. I'm your host, Tony Burke. I make videos on Arista, Juniper, Cisco, BGP, EVP, and VXLAN, networking in general, and especially automation. But today's talk is going to be on BGP Unnumbered. So what is BGP Unnumbered? It's a mechanism for connecting BGP peers together without setting a local IP address and without setting a remote IP address. So we're going to use IPv6 unnumbered or IPv6 link local, and then neighbor discovery to determine what the IP address of the other side is. So everything gets auto configured. In BGP, the only thing you specify is the interface that it's acting on. And if it's a point-to-point link, it'll discover the other side and auto configure it. So several vendors have implementations of this. We're going to do a demonstration of Arista, Cisco, and Juniper for this particular demonstration, but there's other vendors that do it as well. So what are the benefits of BGP Unnumbered? Most of the time, it's going to be just ease of use. We don't need to plan for these point-to-point links. We don't need to set a local IP address and burn up something in our IPv4 space. We don't need to set up a remote address. So it's just going to be easier configuration, easier management. And BGP Unnumbered is done in two parts. So the first part is RFC 8950. So RFC 8950, formerly known as 5549, but 8950 superseded that. You'll often see documentation referred to 5549 as well. Excuse me. And this was what allows an IPv6 next hop to be used for IPv4 prefixes. So IPv4 prefixes, their next hop will be an IPv6 address. The other part is just some built-in features of IPv6, link local addresses, and neighbor discovery. So it auto configures a local address based off the MAC address typically, and then discovers what the other side is using neighbor discovery. So traditionally with BGP peering, of course, then we have to have the IP addresses. So in this case here, we would have /31s. They can be as small as /31s because we don't need a network or broadcast address. But in this case, these are two /31s, and we need to configure them locally, the local IP address, and then configure the remote side on both sides. And that's not really a big deal, but it starts to become an issue if we're starting to do things like lots of point-to-point links. So think about like an EVP and VXLAN fabric. We've got leafs and spines, and there's lots of point-to-point links in those. So in this example here, we've got 3 spines, we've got 4 leafs. That's 3 times 4 times 2 for 2 IP addresses per link. And that's 24 IP addresses or 12 /31s. Not really a big deal, but when we start to scale out, then it becomes pretty cumbersome. So let's say we've got 4 spines and 50 leafs. That's 4 times 50 is 200 times 2. That's 400 IP addresses we have to set on all the devices and neighbor statements, etc. Now, automation can help out a lot with this. There's some tools that can really make this a little bit easier, make this a lot easier. But if we don't have to do this at all, then all the better for it. So now some of the other routing protocols have allowed, like OSPF and ISIS have allowed us, depending on the vendor's implementation, of course, have allowed us to do IP unnumbered. So it's borrowing the IP address of a loopback in order to build these neighbor associations or neighbor relationships. But with BGP, we need an IP address because it's TCP based, while the others are broadcast or multicast based. So here's an example of IPv6 as a next hop. So we have this particular route here, 444/32, and the next hop is going to be that IPv6 address. Now, one of the nice things about IPv6 is the link local addresses are actually useful. Like, I don't think I've ever encountered in my career a link local address for IPv4 that did anything other than tell me that DHCP wasn't working. So whenever I see the 169.254 address, I know that there's something wrong and it's really annoying. But other than that, I don't think link local addresses have really done anything in IPv4. But in IPv6, they're quite useful. Configuring these link local addresses is pretty easy. Here's some methods for some of the various network operating systems. So Arista EOS, make it a layer 3 port. That's no switch port, and then IPv6 enable. That's all we got to do. And then we've got an IPv6 link local address. For NXOS, it's very similar. IPv6 link local, use BIA, that's burnt in address, and then it will generate a dynamic IPv6 address from the MAC address of that interface. And then Juniper, Junos, this is Junos Evolved. I think it's the same in regular Junos. It's set interfaces, unit 0, and then inet 6, and that's all you need. So now we're going to do an example. We have actually got 2 examples. One is between 2 routers, and the other one is between 3 routers. The first one's going to be our example between R1 and R4. So I've got 2 routers here. They're both containerized EOS. And so let's get in with that. They're connected to each other on Ethernet 3 on R1 and Ethernet 1 on R4. So if I go into admin at R1, oh, you know what? I didn't start the Containerlab. So it's CLab deploy. Forgot to do the deploy part. Now, this Containerlab topology, I love Containerlab, by the way. It's one of the best tools out there for labbing learning network operating systems, routing protocols, etc. And I do have a GitHub repository that's going to have all the configs for all the routers, so all 4 routers, Cisco, Juniper, Arista, and then it will also have the Containerlab topology that I used. You just have to make sure that you get the images yourself. Okay, so we've got Arista EOS, we've got Cisco 9KV, Nexus 9000, and then we got Juniper C Junos Evolved. The Cisco and the Juniper one are going to take a little while to start up, but R1 and R4 should be up right now because the containerized EOS, so EOS is the network operating system, the NOS from Arista. They have a containerized version that works fantastic. It's very lightweight. It uses a very little CPU by itself, whereas some of the other vendors have a heavier virtualized instance here. So we're going to go to config mode, and I'm going to go into Ethernet 3. And if I do show LD neighbors, I can see that I'm connected to R4. On R4, it's Ethernet 1. And I'll just do no switch port, IPv6 enable, and that's all we got to do to generate that that link local address. So if I do show IPv6 interfaces, or brief, we can see that we've got this link local address. So where does this link local address come from? There's a couple of options for it, but typically we generate it using the MAC address of that interface. So here's typically how we would do it. So we've got an IPv6, or we've got a MAC address on this interface here. And the first thing we'd typically do is it will flip the 7th bit. So in this case, 00 will become 02. So flipping the 7th bit in a MAC address typically means the 2nd digit of the first octet. So the first octet here is 00, and then it becomes 02. So it'll change the 2nd digit. What they mean when we flip it, if it's 1 or a 0, it means if it's a globally administered MAC address or a locally administered MAC address. Globally administered MAC addresses are those that you'll find burnt into interfaces. Locally administered means they're virtualized or they're assigned locally. We're not going to worry about that now, but we've got a MAC address. We flip the 7th bit, and then we have to, because the MAC address is 48 bits, and we're going to do a /64, so the network part of this address is going to be 64 bits. We have to pad it with FFFE. And if I remember right, the funny kind of story about this, it was supposed to be just all Fs, so FFFF, but there was a typo in the document, and it went out before they could fix the typo, so now it's just FFFE. But that's okay. It doesn't really matter. We use that to generate this 128-bit address. The prefix is going to be FE80, so Foxtrot Echo 80, and that's in a /10. So that'll be our link local address there. And then we take the first part of the MAC address, we put it over here. The second part, we put it over here, and then we put the padding in between. So that's how we get that link local address typically. So on R4, so let's go to R4. And then I'll do the same thing. No switch port, IPv6 enable. And now if I do show IPv6 interface brief, then I've got a link local address as well. So both sides have a link local address. We can actually configure BGP. So a couple of things on R1. We'll do this on both of them. I'm going to do IP routing, IPv6 unicast routing, and then also IP routing IPv6 interfaces. So I think that's what's going to let us use, generally let us use IPv6 as a next hop for IPv4. Not 100% sure. The documentation is not very clear there, but I do know we need it. And then we'll do we'll put a loopback. So loopback 0, IP address 1111. We'll just make it very simple. So now we can go into router BGP. We'll set our router ID. Always set your router ID in a routing protocol. We're going to do neighbor R4 peer group. Was it neighbor? No, peer group. Yep. The neighbor R4 remote AS is going to be 4. So R1 is going to be AS of 1. R4 is going to be AS of 4. We're just going to keep things real simple. And then our neighbor interface E3 is peer group R4. That's all we need to do. So that sets it for our local. It'll use our local link local address on E3, whatever that is. Then it will use neighbor discovery to find out what the other side's IP address is and dynamically configure that peering. So we need to go to address family IPv4. We'll do neighbor R4 activate. And we need to do one more thing, neighbor R4 next hop address family IPv6 originate. So that, again, that's another thing that we have to do to let IPv6 addresses be our next hop for IPv4 routes. And then we'll put the loopback into the routing protocol. There's a couple of different ways we could do this, but this is the simplest way. So we're configured on R1. Excuse me. So R4, doing the same thing. So IP routing, IPv6 routing, or unicast routing, and then IP routing, IPv6 interfaces, interface loopback 0, IP address 4444, and then we can do router BGP4, router ID 444, neighbor R1 is going to be peer group, neighbor R1 remote AS is 1. Then add neighbor interface E1 is peer group R1. And then address family IPv4, neighbor R1 activate, and then neighbor R1 next hop address family IPv6 originate. And then we'll put in the network of 4444 in there. So one thing we can do is we can do show IPv6 neighbors. See if we got any neighbors. So this is the link local. This is the neighbor discovery protocol. So we see the IPv6 address of the neighbor. And if we do show IP BGP summary, still waiting to come up, I think. Show IP BGP summary. It's in connect. So make sure I remember to do everything. Remote AS is 1. Peer group. E1. Sometimes it takes a second. All right, there we go. All right, I had to be patient. So if I do show IP route, you can see that from BGP, I've learned the route of R1, on R4. So if I do ping 1111 source 4444, it works. So that is our demo for R1 and R4. So the next demo I'm going to do is for our Franken fabric. So this is a Frankenstein's fabric built with multiple vendors. So we've got Cisco, we've got Cisco Nexus, we've got Arista CEOS, we've got Junos Junos Evolved. So it's their next generation network operating system. It's not the FreeBSD one, it's based off of Linux. So that's R2 and R3. So let's go into R2. It is test at 1, 2, 3. Oh, yeah, it's admin. It's Cisco. And then R3 is Juniper. All right, there we go. So we're going to do Cisco first. It's a little bit easier for me, at least, just because I'm more familiar with that environment. Juniper is the one I'm least familiar with, least comfortable with. So we're going to do a couple of things that we didn't have to do. A couple of things different. One, we're going to turn on BGP, and we're going to turn on LLDP. So you need to turn those features on. We'll do interface E11 through E2. We'll do no switch port. That turns on, makes them an L3 port. We'll do IP forward so we can forward IPv4 traffic through it. And then IPv6, link local, use burn-in address. So if I do show IPv6 interfaces brief, we've got our link local addresses, so we're good there. Also, we need to do no shut. All right, there we go. I don't know if we did enough to do show IPv6 neighbors. Let's see if we see anything there. No, not yet. Okay. And then we'll do interface loopback 0, IP address 2222/32. And then we can configure BGP. So router BGP2. Takes a second. Router ID, always important. And then we'll do address family IPv4 unicast. Network 2222, that'll put it into the routing protocol. Again, there's other ways to do it, like route maps and so forth, but we're not going to do that. And then next is neighbor Ethernet 1.1. So that's connected to, if I do show LDP neighbors, that's connected to R1. We haven't configured the Juniper device yet, and we haven't configured LDP on that one, so we don't see it yet. That's on Ethernet 1.2, but we do see R1. The remote AS is going to be 1, and then our address family IPv4 unicast, IPv6 unicast. I think we just need IPv6 unicast, but show run. So that's configured there. So if I do show IP BGP summary, again, it'll take a second to auto-discover. Oh, we need to set it on this side too. So that'll be router BGP1. And neighbor R2 is going to be peer group. Neighbor R2 remote AS is 2. The neighbor Ethernet interface, Ethernet 2, is peer group R2. Then address family IPv4, neighbor R2 activate, neighbor R2 next hop, address family IPv6 originate. So that should be enough, I believe. Gotta wait a second for it to auto discover. We're just gonna double check, make sure I've got everything configured. I believe that's it. Okay, show BGP summary or BGP IPv4. Unicast. A lot of moving parts here, so it's easy to get turned around. I just check my notes here because when I set all this out, E2 is R2, R2 peer group, AS2, R2 activate. Make sure I set the AS on it. Oh, it's I had the wrong address, so it's show LDP neighbor. Yeah, it's E1. That was my mistake. So neighbor interface E1 peer group R2. Just get the wires crossed literally. So show IP BGP summary. I'll take a second here. I'll do no neighbor interface E2 peer group R2 just to get rid of that, clean it up, because we're going to need that. We're going to send that IP address to, or that interface to R3. Section BGP. Okay, I think that should do it. And then I'll do no neighbor R2 activate, and then neighbor R2 activate. Oh, I also need to configure that IP address, or that interface. Interface E2. No switch port, IPv6, IPv6 enable. Okay, router BGP 1, IPv4. We'll just do a no neighbor activate and neighbor activate. Brief. So now we do have those addresses. Oh, it's interface 1. It's easy to get really mixed up here. So R1, 6 neighbors. All right, now we see it, and then router BGP. Make sure we're not seeing anything. Okay. Sometimes it takes a second. And we'll just double check our config on R2. Show IPv6 neighbors. Okay, we do see interesting. All right, we're active. So the IPv6 is configured. Show run section BGP. So R2 is on Ethernet 1, peer group R2. And sometimes it takes a second to come up. Unless I'm missing something on here. Ethernet 1.1. That's R1. Let's see if we get an error here. Connect failure. Interesting. We've got two link local addresses coming from that interface. So alpha 8 Charlie 1. So alpha 8 Charlie 1. We're getting this 90 Bravo Charlie. So I wonder if I should shut and unshut the interface. Shut, no shut. Yeah, I don't see where that other address came from. My guess is that it was using the wrong address. Oh, there we go. So that, yeah. I don't know why, but it grabbed, it was detecting another IPv6 address from the other side, and I don't know where, it might have been a weirdness of Containerlabs and how Docker does the network. So that was an interesting thing there. But if I do show IP route now, I see 1111 coming from the BGP session. So I can ping 1111 for the source of 2222, and it works. So now we're going to configure R3. So this one is the biggest challenge for me because, again, I'm not as familiar with Junos. We'll go into config mode, and the first thing we'll do is we're going to set protocols LDP interface all. Commit and quit, and then that's going to turn on LDP. So show LDP neighbors. We should be able to see all of them now. Well, we see R2 at least. And then show run interface, show LDP neighbor. We do see on Ethernet 2, that looks good. All right, we'll continue. So go back into config mode, and we're going to set some interfaces. 000. So these are what's connected to R1 and R2. So R1's connected on 000. So unit 0, family, inet, and inet 6. And we'll do the same thing for 1. So that's connected to R2. Or sorry, R1. And then we'll set a loopback address. So we just did family inet 6, and that's enough to create a link local address. And we'll check that out in just a second here. So unit 0, family inet, address 3333. And then commit and quit, make sure that all works. Show interface ET0. We'll see if it's got a link local address. I think we can see the, yeah. So that's our link local address. And that's our link local address. Okay, so we've got link local addresses. I don't know if it's enough to do show IPv6 neighbors. So that's Ethernet 2. Don't see it yet. That's okay. I don't think we need to see it just yet. Do some more config. We'll do set routing policy. Routing options, rather. I'm looking at my notes here. Router ID will be 3333. Always set your router ID. We'll do some policy statements. I just called it send routes from protocol. Direct, and then then accept. Don't have a good handle on why we need to do it this way. And then we're going to set an AS list so we can allow in different AS numbers, a range of them, 1 and 2, because 1 is R1, 2 is R2 for AS numbers. We'll also do set protocol router advertisement. Oh yeah, I think this is what's going to enable IPv6 neighbor discovery. I think commit quit. Yep, that's what it was. That's neighbor discovery. So .9 :9. So that's there. So we've got neighbor discovery going, or we've got neighbor discovery going on, and then let's configure BGP now for the neighbors. So set protocols BGP group RFC. We're just call this RFC 8950. Again, you'll see RFC 5549 used a lot in terms of the this technology, but it is 5549 is used a lot in the literature, in documentation, in presentations, but it's really 8950 now. Although they both pretty much mean the same thing. 8950, I think, was just a clarification of some things. But anything you do in 5549, you can do in 8950. And so we're going to do family, inet, unicast, and then we'll do extended next hop. So that means, I think that's setting it so that we can have IPv6 as a next hop. IPv6 unicast, family, we're going to do export, send routes. Our local AS we have to set will be 3. And then dynamic neighbor, we're going to call it Franken for Frankenfabric. Pure auto discovery. Family, inet 6. IPv6 neighbor discovery. And then we'll set it on the interfaces for ET000. .0 and 1.0. I don't know why we need to do the .0s after it. And then we need a peer list. Peer, list. And I think that's it. So we'll do commit and quit, see if we got any errors. You will see this in the various virtualized instances of Juniper software. It'll say warning requires a BGP license, but it doesn't. I mean, it does require a license if you want to do production, but this is a lab environment, so it's fine. So if I do show IP BGP summary, oh, I need to configure it on R1 as well and R2. So we got to do it everywhere. Show run BGP section BGP. So as far as I know, R3 is configured all the way. So we'll do neighbor R3 peer group. Neighbor R3 remote AS is 3. Oh, neighbor R3 peer group. Oh, router BGP 1. Neighbor R3 peer group. Neighbor R3 remote AS is 3. And then interface E2 peer group. Oh, sorry, neighbor interface. E2 peer group is R3. It's very easy to get mixed up with E2 being R3, E1 being R2, E3 being R4. It's very easy to mess that up, which I think I already did. And then neighbor R3 activate, and then activate address family, or address family rather. Next hop address family. IPv6 originate. show IP BGP summary. All right, that one came up quick. So if I do show IP route, I see that I have 3333. So if I ping 3333, source 1111, that's my local, and I can ping. So it's all worked. The only thing I need to do now is on R2. And I want to add in the neighbor, so router BGP2, neighbor Ethernet, 1, 2, remote AS is 3, address family IPv4 unicast. So they all do things in a very different way. And one of the things that working through this has taught me is that I really don't want to manage a fabric that's made of multiple vendors. The context switching is a lot more tough on me than I thought it would be. All right, so I've got a neighbor established relationship there, and if I do show IP route, I see I've got both. So I can ping 3333 source 2222, and that works. And I've even got a path to 4444. So, all right. So let me put the link to the lab, to the configs. I'll put it into this video here. Hello, Robin. Welcome to the here. For configs and Containerlab topology. So I'm going to put that into the description of the video. Here. I'll put it into the chat room too. So what we did, just to recap what we did before we sign off, is I built this Franken fabric of Arista, Cisco, and Junos, and we were able to route their loopbacks. And theoretically, you could, practically, you would route other things other than loopbacks, unless it's EVP and VXLAN. Then that might be all you're routing here. But we could do IPv4 routes with IPv6 at the next hop. And we use neighbor discovery in order to configure dynamically configure the BGP peers without one, setting our local IP address, because we just do the link local, and then two, without sending the remote IP address, because we use neighbor discovery. So let me know if you have any questions in the comments down below, and thank you for watching.